Hello, this is Allison Hannon, and today I'll be doing a problem with convolution. So we're going to be convolving x of t with h of t, and as you can see, x of t is a sine graph from 0 to 2 pi, and h of t is a shifted rect function. So when we go and convolve, our h of t is going to be turned into h of t minus tau, which is going to look something like this. So we're going to have t minus 3 and t minus 1. And so that's our h of t minus tau. And then our x of tau will look basically exactly like x of t. So I'm not going to go and redraw that. So for t minus 1 is less than 0, which would be t is less than 1, then this function is just going to be equal to 0 because our rect function will not have hit the sine graph yet, so y of t will just simply equal 0. But then, when we get to t is greater than 1, so from 1 less than t less than 3, so before our t minus 3 end of the rect function hits the sine wave, but after t minus 1 hits the sine wave, then y of t is going to be equal to the integral of 0 to t minus 1 of sine of tau. And that's going to equal the negative cosine of tau from 0 to t minus 1. So then when we do that out, we're just going to get cosine of 0 is 1 minus cosine of t minus 1. And then after that, we're going to be doing t is greater than 3 and t is less than 3 pi. So for 3 is less than t less than 3 pi. So now our t minus 3 line is on past our 0 axis, so the rect function is totally on top of our sine wave. So our integral is going to be y of t is equal to the integral of t minus 3, because we're going from the rect function, we're basically just doing the rect function, so to t minus 1 of the sine of tau. And so that's going to give us, again, the negative cosine of tau, but this one's going to be going from t minus 1 to t minus 3, which means that when we put that one out, it's going to be cosine of t minus 3 minus the cosine of t minus 1. And then after that, we have t is greater than 3 pi and t is less than 6 pi. So now our t minus 1 is past our sine wave, but our t minus 3 is still over it, so we'll be going from t minus 3 to 2 pi. So our y of t is the integral from t minus 3, to 2 pi, and of sine of tau. And that equals negative cosine of tau from t minus 3 to 2 pi, which equals the cosine of t minus 3 minus the cosine of 2 pi, which is just 1. Okay, so finally we have 6 pi is less than t, and for this one, y of t is again z equal to 0, because like when we had t is less than 1, we had the rect function on the left side of our sine graph. Now it's on the right side, and it's not touching it at all, no overlap, so it's just equal to 0. So for our final answer, we have y of t is equal to 0 for t is less than 1, and then for 1 minus cosine of t minus 1 for 1 1 is less than t less than 3, and it's equal to the cosine of t minus 3 minus the cosine of t minus 1, for 3 is less than t less than 3 pi, and cosine of t minus 3 minus 1 for 3 pi is less than t less than 6 pi, and then 0 for 6 pi is less than t. Thank you for watching.